Alright, so we're going to look at a problem now that requires a little bit of implicit differentiation, and this is not such a bad thing really because it allows us to take a derivative of any problem at all as long as we know which variables we're working with. And in this case we're working with x and y, and we can take derivatives of those. So a real quick setup side note thing before we dig into implicit differentiation. If I give you something that looks like y equals 3x squared plus 7x, and I say, okay kids, I want to know what the derivative of this is, then you would write this: dy dx equals 6x plus 7. Well, what we're really interested in for today's lesson is this dy dx part right here. That is the derivative of y. That's what the derivative of y is. It's dy dx. So anytime you take derivative of y, you're going to have dy dx. Okay? Alright, good talk. Here we go. So let's go ahead and look at what we've got going on here. We've got 2x squared times y. And this is full effect product rule. Why? Because I have 2x squared, that's one function, times y, which is another whole deal. Okay? It's not a constant times something. It's two separate things. So when I work this problem out, I'm going to take the first term times the derivative of the second. Wait a second. What's the derivative of y? It's this guy right here. Bing, 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 bing. Derivative of y. So 2x squared times dy dx plus the derivative of the first term, which is going to be 4x, times the second term, which is just y, minus, and then I've got pi times the derivative of cosine y. Well, derivative of cosine is negative sine of y times the derivative of y. What's the derivative of y? Ding, 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 dy dx. And then I go ahead and take derivative on the other side, which is 3 pi, and hey, the derivative of a constant is 0. Remember, a derivative is rate of change. So if you have a number that's constant, you don't have rate of change. And if you don't have rate of change, you have 0 rate of change. Okay? Now, let's just clear this up just a little bit here. So I have 2x squared dy dx plus 4xy plus pi sine y dy dx. Now, in order to find tangent of a curve, I need to find the derivative. I need to find dy dx. That's where I get my rate of change relationship. Notice over here on the right, highlighted in pink and surrounded by green arrows, that's my derivative relationship. That's what I need. So what I'm going to do is I'm going to take these terms that don't have dy dx in them, and I'm going to subtract every one of those suckers I can find to the other side. And as it turns out, it's only one. How great is that? So 2x squared dy dx plus pi sine dy dx equals negative 4xy. And then look at here, look at here, look at here, look at this. Check this out. Right here, and right here, dy dx's. Factor them out. And when you do that, that's going to leave you with 2x squared plus pi sine y equals negative 4xy. Now, this was a plain old algebra problem from your Algebra 1 class eons ago. What would you do to get dy dx by itself? I'll give you a second to think while I write it down. Go ahead and talk amongst yourselves. Think about it. That's right. You're going to divide both sides by the thing multiplying dy dx. So here's my rate of change. Here's my dy dx right here. Dy dx right here. So what I need to do is I need to find the equation of the tangent line. Well, now I've got a way to do that. And what is my way to do that? Well, all I need to do is find the point that I'm interested in for the slope. And I've been told that point, like I've been given that specific point right here, when the x-coordinate is 1 and the y-coordinate is pi. So what does that mean for us? That means that we're going to substitute into this equation pi for y, 1 for x. So -4 times 1. So remember, here's x, here's y. I just need slope. So we're going to do that. Times pi over 2 times 1 squared plus pi times sine of pi. Okay, now clean this up, work it out a little bit, get comfortable with it, make it yours. And when we do that, what happens is the sine of pi is 0. So this whole part over here drops off. On the top, I know that -4 times 1 times pi is -4 pi. And on the bottom, I know that I've got 2 times 1 squared, or 2. So my slope is going to be -2 pi. If I have an x-coordinate, a y-coordinate, and a slope, I can write the equation of the line. So that equation is going to be y minus the y-coordinate, which is equal to the slope, -2 pi, times x minus the x-coordinate. And I'm comfortable with this answer. The only other thing you might want to do if you want to be, kind of cool, is move over the pi. There's no need to distribute. I know exactly what this equation looks like. I can graph it without a problem. You don't need to write it as just y equals blah, blah, blah. If you want to do that and reduce it, I don't have a problem with it. I am not going to make you do it. Okay? So there's finding the tangent line to a curve using implicit differentiation.